Find the center and radius of a circle with the equation x squared plus y squared minus 4x plus 6y minus 3 equal to 0. In this problem, if you observe, you see that the equation of the circle has been given to us in the form x squared plus y squared plus px plus qy equal to what? Plus r equal to what? Equal to 0. Has been given to us in this form. And in our last lesson, we had established that if we are given the equation of a circle in the alternate form or the alternative form, we said that the center of the circle C, H, K gives us what? Gives us minus P over 2 minus Q over 2. And that the radius of the circle R gives us what? The square root of P squared plus Q squared minus 4R divided by what? Divided by 2. So in this problem, all we need to do is compare the given equation of the circle with the general alternative form of the circle. So if we compare these two equations, what do we observe? X squared, y squared, P. So we see that P is what? Negative 4. Our Q is what? Is 6. And our R is what? Negative 3. Negative 3. So with this information, we will be able to compute the center of the circle as well as what? The radius of the circle. So is it the center? So the center C with coordinate h, k is equal to what? C, the h coordinate is minus p over 2. So the center is minus p. Minus, what is p? P is minus 4. So minus 4 over 2, comma, and what is q? And what is k? K is minus q over 2 minus q. What is q? Q is 6 minus 6 over 2. If you compute this, what do we get? We get that the center is minus times minus 4 is 4 over 2, comma, minus what? 6 over 2. And that gives us the center to be 2, comma, negative 3. To find the radius, we employ this other formula. So the radius of the circle is the square root of p squared. What is p? Our p is minus 4. So minus 4 squared plus q squared. Our q is 6 plus 6 squared minus 4 times r. Our r is what? Minus 3. Divide by what? 2. That gives us the square root of minus 4 squared is what? 16 plus 6 squared is what? 36 minus 4 times minus 3 is plus what? 12 divided by what? 2. So let's start this up further. We get the square root of, now 16 plus 36 is what? Is 52. 52 plus 12 is 64. Square root of 64 over 2. And that gives us 8 over 2 equal to 4. So what do we get? So we conclude. So therefore, the center of the circle CHK is what? The coordinate are what? 2 and negative 3. And the radius of the circle R is what? Is 4. Now take note. If you like, at this point, you can go ahead and complete the squares on this equation. You know, we have x squared plus y squared minus 4x plus 6y minus 3 equal to 0. So if you like, you can complete the squares on x as well as complete the squares on y. And you see arrive at the same answer for center and radius. But that process is rather too long. Why not just use the center coordinate as minus p over 2 and the radius as this formula? We shall take the second example. Example. Find an equation of the tangent to the circle x squared plus y squared plus 2x minus 2y minus 39 equal to 0 at the point P with coordinate 3 and negative 4. So let us try to visualize what this problem is saying. So we have a circle centered at some point which we do not know. Centered at a point which we do not know. So now the circle passes through the point. Okay, that there's a tangent to the circle. What is a tangent? Tangent means a line that touches the circle just at one point. That's a tangent. And that tangent, the point of tangency is what? P, 3, and negative what? 4. Question says, find an equation of the tangent of this tangent. And what do you observe? A tangent is nothing but what? A straight line to the circle. Now let us try to understand what is happening here. To find the equation of this tangent, this is just a straight line. We need two things. In our last lecture or in our previous lectures, we have discussed that to find the equation of a straight line, once we have one point on the line, as well as what? A slope, that we will be able to find the equation of that line. Now for this tangent, let us call this tangent line L1. What do we observe? This line passes through the point 3 and minus 4. So we have 1 point. However, we do not know the slope of this line. So that's a problem. But at the point of tangency, a line drawn from the center to this point becomes perpendicular to the tangent from our circle geometry theorems. If we draw a line from the center of the circle to the circumference of the circle at this point P, where there is a tangent line, then at that point there's a 90 degrees angle. And what does this imply? It implies that this line L1 and the radius, which we are now call line L2, are perpendicular. What does this mean to us? Since we want the slope of line L1 and line L2 moves from the center to this point P, if we are able to establish the slope of line L2, then using our slope relationship, we will be able to establish what the slope of line L1 shall be. But we cannot know what the slope of line L2 will be unless we have 2 points. So we have the first point here, 3, minus 4, and the second point would have been the center of the circle, but we do not know what the center coordinates are. However, we can establish what the center coordinate of this circle will be from the formula, from the equation of the circle. The equation of the circle is what? Is x squared plus y squared plus 2x minus 2y minus 39 equal to 0. If we compare this equation again to the alternative form of equation, which is x squared plus y squared plus px plus qy plus r equal to 0, what do we get? We get that our p is what? Is 2. Our q is what? Negative 2. And our r is what? Minus 39. So what do we need? We want to find the center of the circle. And from the alternative form of equation, we know that the center coordinate C, HK is nothing but what? Minus P over 2 minus Q over what? Over 2. And this gives us center to be what? Minus P is 2. So minus 2 over 2 is minus 1. And then Q is minus 2. So minus 2 over 2 is 1. So we have now seen that the center of the circle is nothing but minus 1, 1. Now that we've known the center of the circle, it means that for line L2, we now have 2 points. Line L2 goes to the point minus 1 and 1, as well as 3 and minus 4. So with this, we can establish the slope of line L2 as follows. Now, so the slope M1 of line, L2 of line L2 is equal to what? What is slope? Y2 minus Y1 over X2 minus X1. You may want to recall, you may want to refer to our videos on straight lines or slopes of straight lines. So if we call the first point here X1, Y1 and call here X2, Y2, what do we get? The slope now becomes Y2 is minus 4 minus Y1 is 1 over X2 is 3 minus X1 is minus 1, that is plus 1. And that gives us minus 5 over 4. So that is the slope of line L2. Since line L2 and L1 are perpendicular, what do we know? We know that the slope M1, M2 is equal to minus 1. We know from our parallel lines and perpendicular lines that the slope, that the product of the slope of perpendicular lines is always negative 1. What we want is the slope of line L1, because it is the line L1 that will require the equation. So, having known the slope M2 of line L2, we can now know the slope of line L1 as follows. So, M1 we do not know, but M2 we know as minus 5 over 4 equal to what? Minus 1. So, we can rearrange this term, and what do we get? We get that minus 5 M1 is equal to minus what? 4. So that M1 is equal to what? 4 over 5. So this is the slope of line L1. So we now know that for the tangent we are looking for, we now have the slope of that tangent, M1, as what? As 4 over 5. We have also one point of the line, P3, minus 4. So if we use our point slope, form, we have y minus y1 equal to m into x minus x1. So we have y minus, what is our y1? Our y1 is minus 4, so that is y plus 4 equal to m, is the slope of the line, which is 4 over 5 into x minus x1. And what's our x1? Our x1 is 3. And what we have here now becomes the equation of this tangent to the circle at the points 3 and negative 4. Of course, you can go ahead to expand this equation and leave your equation in what you call the slope intercept form. I hope you understand the problem.